Welcome to one of my all-time favorite topics, trigonometry. You can kind of see that at the top here. Okay, this is a summarization of what you should have learned during fourth term last year, which means that you were at home learning online. So if you remember pieces of this, awesome. If not, we're going to do our best to review it and use it so you can remember it and succeed this year. Okay? So trigonometry is talking about sine, cosine, and tangent. If you remember, you may have learned a little silly phrase or word here, SOHCAHTOA. And what this stood for was the sine equals opposite over hypotenuse. We'll put that into context here in a second. Cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Okay? So this was the setup. All this is the ratio of those two sides. Well, how do we know which side is which? That's why we have an angle. This variable here, this is called theta. Okay? So my angle I'm saying is theta. So that's why this says sine of theta. Theta is the angle I'm looking at. Sine uses opposite over hypotenuse. Based off this angle, the opposite side is 4. And the side opposite the 90 is always the hypotenuse. So my sine of theta here is 4 over 5. Cosine of theta, that same angle, cosine uses adjacent over hypotenuse. This side, the 3, is the adjacent side. It is adjacent to the angle. So adjacent over hypotenuse, that is 3 over 5. And tangent of theta. Tangent is opposite over adjacent, so 4 over 3. And that's all it's asking us to find, is to set up those ratios, recognizing those side lengths, opposite and adjacent and hypotenuse, and then which ratio goes to which trig value. Yeah? Yes? No? Cool? All right. So we've got a second one set up here. We have a problem. I'm missing a side length. To find that side length, we're going to use the Pythagorean theorem. So we have a squared plus b squared equals c squared. When we use the Pythagorean theorem, c always has to be the hypotenuse. So that's going to be my 13 here. And then we'll say 5 is a, so we're solving for the side b. So this is 25 plus b squared equals 169. I'm going to minus the 25 over. So b squared equals 144. And I square root both sides, and I get plus or minus 12. Because we're talking about the side length of a triangle, we're going to go ahead and ignore the negative 12 since our distance can't be negative. We're not dealing with direction yet. We'll talk about that later. My side length here is 12. Okay, these two examples, these triangles, are both using Pythagorean triples. They are 3 integers that satisfy the Pythagorean theorem. If you recognize that this is a 3, 4, 5 triangle, or in the future, if you recognize a 3, 4, 5 triangle, you can just fill in those sides without having to resort to the Pythagorean theorem. This one, this is a 5, 12, 13. If you know those relationships, that's going to save you time, especially if you're doing the ACT coming up. Okay, something to look into. Okay, this triangle over here, theta was down in this corner. Now we're using a new variable. This is called beta. Beta is here, so now my opposite side might change a little. It might look different. So opposite of b is 12. So sine of beta is going to be 12 over the hypotenuse of 13. Cosine of beta, the adjacent side here is 5. So this is going to be 5 over 13. And tangent of beta is opposite over adjacent. So we're going to have 12 over 5. Okay, go forward, practice. Let me know if you got questions.